In late June 2026, a freight train derailed outside Bullabygd, Sweden. The solid steel tracks beneath it had warped and buckled under intense heat. Further south, the electrical grid in Turin, Italy collapsed. As temperatures spiked, millions of air conditioners and cooling units drew more power than the system could handle, triggering rolling blackouts across the city. European cities were designed to survive the cold. From the thickness of the residential walls to the layout of the transit lines, the infrastructure was built to retain heat for long freezing winters, leaving the continent highly vulnerable to consecutive days of 40-degree heat. Looking at this animated data map from the Callahan mortality study, we can see exactly what that vulnerability cost. Between June 22nd and June 28th, expanding red points tracked 20,390 heat-related deaths. That mortality count spanned the entire continent. France recorded over 2,000 fatalities, while Belgium and Spain each saw over 1,000 people die in a matter of days. Bridges cracked, railways warped, and thousands died. The collapse of these systems exposed a fatal unpreparedness across the developed world. The sheer intensity of the temperatures broke historical records. In Spain, digital street signs displayed a staggering peak of 45.1 degrees Celsius. This illustrates the meteorological trigger, an omega block. Atmospheric currents bent into a massive U-shape, trapping a high-pressure dome over the continent. This dome acted as a physical lid, pushing away incoming cool Atlantic fronts, forcing hot air downward and baking the surface. Thermal imagery from the Copernicus Sentinel-3 satellite confirmed the resulting ground conditions. The surface temperatures far exceeded historical norms, absorbing and radiating extreme heat back into the cities. Researchers at Carbon Brief analyzed the data and found a clear climate amplifier effect. Reaching and sustaining this level of extreme heat would be virtually impossible without the underlying warming caused by human activity. Rising global temperatures provided a higher baseline, turning a standard atmospheric block into a stationary, deadly heat engine. Inside those cities, residential architecture became a major hazard. Because extreme summer heat has historically been rare, air conditioning is uncommon in European homes, leaving the elderly and vulnerable trapped in apartments that functioned like ovens. Outside, public transit systems failed. Major rail providers in the Netherlands, including NS and ProRail, had to pull trains from service because the steel components and tracks were too hot to operate safely. Desperate to keep physical infrastructure from cracking, governments resorted to reactive countermeasures. Dutch road authorities sent out trucks to spray salt on melting asphalt and doused bridges with water just to lower the temperature of the steel. The lack of rainfall and weeks of heat also dried up critical waterways. Italy's Po River, essential for the region's agriculture, was reduced to a cracked riverbed, leaving boats stranded in the dirt. Hosing down bridges and halting trains are temporary band-aids. They expose a survival strategy reliant on frantic daily reactions rather than structural resilience. The scale of the crisis prompted a severe directive from the World Health Organization. They warned that European governments must now prepare their health systems for summer heat with the exact same resources they use for the annual winter flu. Hospitals across the continent are already adopting these strategies. Emergency rooms are overhauling their triage protocols to handle massive, predictable surges in dehydration, heat exhaustion, and respiratory failure. Civilian schedules are being rewritten to avoid the midday sun. Major public events, including the Werchter Boutique Festival in Belgium and Pride marches in France, were postponed or canceled outright. Citizens are now forced to seek out cooling resources in public squares. Misting stations and fountains have become essential survival tools for anyone navigating the city. These shifts in behavior represent a cultural surrender. Europeans are altering their traditions, working hours, and daily routines just to safely exist in their own neighborhoods. The summer of 2026 set a new baseline for Europe. While political debates often focus on the short-term fix of installing more air conditioners, the long-term reality requires redesigning urban spaces entirely. City planners must urgently rebuild these environments. Integrating dense green spaces, reflective building materials, and shaded corridors is the only way to mitigate this level of trapped heat. Until the continent's architecture and transit networks adapt to this new climate reality, every upcoming summer carries the risk of matching or exceeding the catastrophic death toll of 2026.